And we'll go ahead and get going here. So I just want to thank everyone for joining us in our Wednesday webinar series. Today, we're actually going to take a look at some of the unusual types of construction that is out there for us for, residential applications, which this, I have to say, this is always a fun one to do for Colorado. Only because if you think about it, we do have a lot of different types of construction that goes on out here. Sometimes we have designs that are not normally seen, all throughout the country. So today we're going to hit upon a couple of them, and hopefully I picked the right ones for today, and we'll just take a look at it. So the first one I want to talk about are shipping containers. How many of you right now have had the opportunity of a project coming in that was going to be built out of shipping containers? Raise your hand. Anyone? All right, Todd, you've had some fun with that. Yeah, me too. I've had it both on the residential side and the commercial side, but today we're going to focus on residential. So when it comes to shipping containers, last time I checked in the energy code, there isn't a section that specifically deals with how do I deal with alternative types of construction, and that alternative types of construction being a shipping container. So there are a few things that we need to think about when we are going to either review it, design a project, or have to build and inspect these types of projects. And so the first thing I'm going to say is, which really can be said for any project, honestly, is you have to know which compliance path you're going to utilize. Because that really does tell how are you going to treat the thermal envelope? How are you going to deal with the systems? How are you dealing with the electrical and lighting, and then your additional efficiencies, right? So the compliance path really determines how you're going to navigate things. And it's especially important to know that when we start talking about shipping containers. Now, when it comes to shipping containers, the compliance path that should be utilized if you're going prescriptive is going to be that U factor option going on in there. You can, from my understanding, you still can utilize, depending on the edition of the code that you're on, the total building performance / simulated building performance, right? Just depends on what edition, or the ERI. I've had conversations and projects that actually, or they said that they did a project that was utilizing ERI or performance path. But the run-of-the-mill typical option that would be utilized is going to be that U factor. And that's the one that is that assembly approach. And so in that assembly approach, it's not just that R value, and it's not, and the reason why you would want to do that is because the design of those shipping containers is not a wood framed wall, which quite honestly, when we look at the table, that's typically what we're dealing with, right? The R value in the cavity. Well, shipping containers don't typically have that cavity. Plus we got metal. So this is basically like, if we thought about this from the commercial perspective, where we have metal on metal, we have to ensure, one, that we aren't creating, condensation and things of that nature that we wouldn't necessarily worry about when we are talking about, wood sheathing or anything of that nature. So really, when we talk about shipping containers, that U factor assembly is incredibly intuitive in dealing with some of the unusual type of construction that would go on out there. And quite honestly, as an interpretation from Chris Stinger at ICC, is that the compliance path that should be utilized for shipping containers actually is that U factor in there. Now, here's an example of, you know, like how that process would work. I've shown you, you know, how to do an assembly for a typical traditional type of wall. This is kind of a breakdown of how the assembly would work for a shipping container type wall. So we have in here, we have our rain screen system going on. We have our corrugated steel wall, which is what our shipping container is, right? And then we have a wood framing that's getting utilized basically to kind of create for the gypboard to be placed on the interior, because typically on the exterior of the building, they really want it to be known that, hey, I'm using a shipping container. But on the interior side, obviously there are things that they have to do. They have to have some sort of insulation going on in there. And so they wanted to typically, or what they usually do, is they have a gypboard finish on the interior side. And so in this design, they do have where they're showing a wood framing and some insulation that's going into that particular framing in there. And then if we come down here, it basically gives us the breakdown of what the design, the U factors for that actually ends up being. So as a total, this wall assembly is a 0.18 as far as the design for a wall. Now remember, it's a 0.182. And if we came over here and looked, the U factor for our wall would exceed the values that are listed right here. Now this, again, it's not providing a whole lot of information for us that's going to give us to be able to meet compliance, but it gives an idea. So we would then take a look in these tables and then follow what the tables are. This happens to be the 2024 table, but obviously if you're on the 18, you'll look at the 18 table, follow what the parameters are in there, do the 21. The last shipping container house that I did was under the 2018 edition, because that's what the jurisdiction is currently on. And it was a really unique type of setup. So here's what I'm going to ask you in this. I just got done saying, hey, you use the prescriptive U factor, right, in determining it. And then what I ended up having was shipping containers being utilized, but also containing conventional construction. So I would have that the exterior, like it had a great design. We had one here, one up. And then, you know, coming around, we had a couple that were stacked on top of each other. But basically, like the interior, it was like they had shipping containers going around the exterior to, again, show that I'm doing shipping containers. And then the interior side, or the interior portion of the building, was stick framed. So that made it kind of interesting, because then you're kind of jostling back and forth between what you would utilize in here. Now, when we start talking about other areas, because obviously we aren't just looking at walls, but I think for the most part, when you talk about shipping containers, it's the walls that everybody thinks of. How do I deal with those walls? Well, you also have to think about how are you going to deal with that ceiling or roof space, right? If it was a, I don't know, you had a few shipping containers stacked on top of each other, and that's what you have, and you wanted to only install like an R30 in that attic, because you're like, the roof is less than, 500 square feet. There's not a whole lot going on there. I want to use the 402.2.2 that says in the rafter space or the ceiling space that doesn't have an attic, I can reduce that insulation value down to an R30. So the question is, would you be able to utilize that option for shipping containers? How many of you say yes, you could use the option for shipping containers? Raise your hand. Sorry, when I do that, that means raise your hand. How many of you say no, you cannot use it for shipping containers? Raise your hand. Okay. How many of you say, I'm just not sure and I can't wait to hear the answer from you, Hope? All right. Oh, okay. Well, the reality is, depending on the addition of the code, will state whether or not that is plausible. If you look in the 18 and the 21, it talks about it's only permitted for that R value option of the prescriptive path. So because this is utilizing the U factor option, they would not be able to use that reduction of insulation for the amount of that shipping container portion. So that's something to kind of be aware of. You know, it's an option, and I like to throw that out there as an option, but unfortunately with utilizing the U factor, it's just not plausible. Now, the other thing to keep in mind, it's not just the insulation, obviously, that you have to think about when it comes to the thermal envelope, right? We have to think about how are we dealing with it for our air barriers and air sealing. So 1821, you're going to follow the parameters that we have in 402.4.1.1. And if you're on the 24, it would be 402.5.1.1. Now, the major differences, I think, in thinking about this is typically I get engineering information about how things are going to be sealed because they have to ensure that the you know, the materials that are going to be utilized are going to be compatible. And I have to say that I probably get more information as far as energy with the shipping container projects that I've utilized than some of the other projects that have been given, that, you know, from builders and contractors that have been building forever and a day as far as demonstrating compliance. And I think part of that is because there's that mystification, I guess, about what am I going to do? How do I deal this? Because now I'm dealing with a steel structure as opposed to what we're all familiar with, you know, the typical type of wood construction. So the other thing to keep in mind with, I think when everything is said and done, the thermal envelope is the biggest aspect of the shipping container and the energy code that is the biggest question. Once you're able to navigate and utilize, you know, the U factor path, get everything all designed and corrected in that way, after that, the project is basically just like everything else, right? The mechanical systems are going to follow all of the requirements out of R403. We're going to get a manual JDNS. We're going to, you know, have our ducts sealed and insulated if needed. We're going to ensure that there's a thermostat. We're going to have, if we have mechanical systems, hydronic mechanical systems, they'll be insulated where they're supposed to be insulated. Our water pipes are going to be insulated. We're going to do our duct leakage test. We're going to do our ventilation test. Outside of the thermal envelope, there really isn't anything when it comes to shipping containers that are really a novelty, right? Oh yeah, so here's an example of actually one of my shipping container projects. But when it comes to, you know, the electrical and the lighting, you know, they're going to follow what 404 has for you, whether it's just everything has to be high efficacy in, you know, if you're under the 18 or if you're under the 21, we got all high efficacy. And then we have certain controls that have to be placed in certain areas. And then in the 21, following the parameters, all of the parameters, or 24, all the parameters that we have in section 404 that includes the lighting and the controls and so forth with that. Now, the one thing that is going to be interesting, because if you think about it, you're utilizing that U factor of the compliance path. So that's going to entail that you're going to need to do the additional efficiency packages options if you're on the 21, and if you're on the 24, what the requirements are. So the major difference is, for 408, it's pick one and be done. 408 for the 24, it's a little bit more detailed. You have to get a certain number of credits depending on a design and depending on fuel sources and so forth, your size of the structure and all of that kind of plays into it. And so because of that, there are some more nuances to that. And those nuances may be affected by the fact that it is going to be a shipping container, as opposed to maybe some more of the conventional type of construction on that. Any questions about shipping containers and how to address them with the energy code? Because I know that that was a quick run through. I usually spend an hour just on shipping containers when I do this class. All right, then we are going to have fun and move along to solar. Now, this is not like putting solar panels on a building. We're going to talk about passive solar because passive solar designs are becoming more pertinent in the, I'd say, southwest area of the country. So there's a difference between passive solar and active solar. So passive solar is a wonderful design where you take into account a whole lot of parameters and design a building that is really going to optimize the heat and light to be conducive to the occupants of that particular structure. Now, active solar is basically where you have a device and you're collecting the solar and converting it into energy, right? But we're talking about passive solar. So there are some things to keep in mind. You have to have a site design, right? The site design needs has to think about where am I placing my windows? And so part of that is, okay, so my windows are going to be, my major windows that are going to be part of my passive solar are facing the south, right? And it's facing south. You have to think about whether where you're placing this on the property is fit to have it. Because if you are in a development and everything around you has been developed for the most part, and you're going to put it, is there anything currently in place that's going to hinder the sun entering into those south-facing windows? If there is, then that might not be the best design for you. You also have to think about your landscaping because sometimes those are two separate dots in the road, and we need to make sure that those dots are connected. And part of that is because part of the strategy, and we'll talk about that here in a minute, is placement of your landscape, because there are certain portions of landscape like trees that are important to have because they help with the comfortability of what's going to happen within the home itself. So we do need to think about things like the orientation. So south facing should be about 30 degrees. And the idea is, right, that you're getting the early morning sun when you should be getting it when it's a benefit, and then the late afternoon sun as a benefit when it's needed. And I say that when it's needed because we'll talk about that. So let's think about what our building needs are. So when we talk about our building needs, the idea is that this building is going to be very energy efficient because what it does is it does help in reducing what your heating and cooling loads are going to be. In that building, you're going to incorporate 5 elements for it to be considered or to be useful as a passive solar design. You're also going to have to think about There are different types of gain that you need to determine what you're going to incorporate in the design. And there happens to be 3 of them. Don't worry, we're going to talk about it. Now, how many of you have had the opportunity of working with a passive solar design? And oh, sorry, raise your hand. Yeah, I actually can say that the house that I currently live in, they did a really good job as far as placement of trees, where the windows reside, because we do really work with the sun in all of this. And I'll explain that. That was my lead in to this, right? Because a lot of people say if we're doing passive solar and we're not really utilizing anything other than the sun to, you know, bring in and condition our spaces in the wintertime, that can become an issue. And this is how we help our structure to be able to, you know, maintain the comfortability is where our windows are. We plan it because we have sun in the wintertime that's at a lower setting, I don't know what you want to call it, placement in the sky. So then, and here's our windows and it's here. The sun can come through here and it can be captured inside the structure itself to help release the heat and absorb the heat as needed within there. And, you know, there are a few options, and you say that's great for the wintertime, Hope. But in the summer, I don't really want the sun to be inside collecting in my home. And you're absolutely right. So that's where we have to ensure that we have shading strategies. And part of that is here's our overhang, right? We want to ensure that we have an overhang. So when the summer sun is set in a position higher up than what it would be in the wintertime, that the sun that's coming down at that spot is actually hitting our larger overhang. So all that it's doing is it's not penetrating into the window and into the home itself. The shade or the overhang is ensuring that it's blocking that sun and that heat from actually entering into the building. And then it also creates the shade for that building itself. And again, with this, we have to think about the ventilation component with it. So typically a lot of times, especially in the summer, there'll be like a purge that purges out the amount of heat that's coming in throughout the day. It purges out, and then you have the cool air that replaces it. So when it comes to the energy code, obviously the energy code does not have a section in there about, you know, what do we do for our thermal envelope if it happens to be passive solar, because there are some unique needs that a passive solar home is going to require. So we do have to ensure that we have a very strong thermal envelope and that we pay attention to the parameters that would be involved with it. Very importantly, obviously, that we have that insulation installed correctly and it's installed in the correct location. Air barriers are included. Air sealing is included because we want to ensure, especially when we're talking about passive solar, that we have the correct, that we are keeping the conditioning in the home where we need to. Now, I have a lot of people that says, you know, how does that work when we have all of that trying to come into and collect it? And I guess I'll wait till that slide. But anyway, so here are the 5 elements that we have here. We have our aperture or collector. So that would be the south facing window, right? We were talking about that. That's where we allow for that sunlight to enter into the home, where it is not being interrupted by our shading efforts that we use for the summertime. And so this is also where we have to think about, you know, other buildings, other trees, making sure that wherever our aperture or collector is, that it is in a prime location. This is where it really is location, location, location. The next thing is our absorber. So our absorber is some sort of hard surface. It's usually a darker surface. And this is where we're absorbing the heat from the, basically collecting it from the outside. There's a lot of designs for that, and we'll talk about some of it. But usually what you're going to see is it's going to be a wall or it's going to be a floor. And that has to be known too, because there are different things that we're going to want to pay attention to. You also have to have a thermal mass. And that means this thermal mass is the material that is going to store that heat. And typically what we find that is utilized for this is going to be things like concrete, brick, stone, tile, because those have a really good ability to absorb it and keep it and transfer it as needed. So this is when it's going to collect the heat from the outside and bring it in for the winter. And then this is the material that's going to collect it from inside the house in the summer to release it on the exterior there. Now, when we talk about thermal mass, I just want to talk about the thermal mass really quick. So a lot of times people ask about, how long does it take for it to kind of transfer through? So for every inch of your thermal mass that you have equates to about an hour. So you start in the beginning of the day and you have an 8-inch wall. It's going to be, if you have the sun out and ready to go or whatever at 6 a.m., at 6 a.m., heat that hits that front of the wall, the beginning of the wall there, it's at 2 o'clock that heat has transferred through that wall system into the structure itself. And the same can be said going in the opposite direction, right? It's taking it and moving it that way. So remember that's kind of how that thermal mass works for it. Now, keeping in mind when we're talking about solar design, it's the distribution too. We also have to have it. It can't just stay in this one wall and just enter in that single room. It has to be have a way of distributing it. So there are basically 3 ways that you can do it. You can do it with natural conduction, convection, and through radiation. So conduction is where it's like heat that is transferable, like from an iron, right? If you touched an iron, that's heat that's getting transferred into the what do I want to say, on the clothes, whatever. Convection, it's moving around. So it's where it's changing from one form into another. So it's like boiling water, right? You have water, you boil it, it turns into steam. That change in form, I can't think of the word I want to use now. And then of course, radiation. Now, the last one is your control strategies. And this is where you have to think about, okay, so in the summertime, I know that I don't want my south-facing window to be taking all of that heat, or my west-facing windows to take in all that heat. So I'll have overhangs. Maybe I have some blinds that I utilize also, some shades, but also trees. And somebody has mentioned to me, well, why would you say trees? Because you just said you got to pay attention to your landscaping. So why am I going to put a tree there? Because doesn't that hinder me for in the winter? But the reality is, in the summertime, it is all fuller leaves. It's full, it's blocking the sun, and it's doing its job, creating shade onto that window. So it's not, absorbing all that heat in the summertime. In the wintertime, it's bare. Typically, most of them are bare, right? We don't have the leaves on there. So basically that sun doesn't have a whole lot of blockage to hinder the heat from the sun into entering these passive solar designs. So anyway, here's an example of all 5 of them working together, creating this passive solar design. Now, there are 3 options we have to talk about as far as the gains, and it's basically how are you going to work the sun into the design, right? How are you going to get it into the structure? So you have direct gains in this one, or the first one. And this is basically you have a window, the sun is coming directly on it. It's going to either hit a mass wall or it's going to hit a mass floor. And that wall or floor stores the heat, keeps it there, and releases it throughout the day, right? And especially, you know, like at night, because it takes a while, obviously, for it to come in and do all that. And so that's when it usually happens. There have been instances where people have utilized containers filled with water as their mass for this design, but there's an awful lot that's involved in trying to utilize that. I have it on there, but it's not something that I would necessarily recommend. And then here's an example of a design of a home that was constructed utilizing that particular option. If you looked at this house, how many of you would say it's a passive solar house just by looking from the outside here? Anyone? Okay. How many of you could say, oh, I see where the mass wall is located in this design? Raise your hand, sorry. So some of you can tell that this could be a passive solar. I'm guessing the biggest tip off is the fact that they have very large overhangs. And, you know, large overhangs went out of style. And unfortunately, I wish they would come back because it does really reduce, you know, your energy impact in the summer and even in the winter too. Think about shoveling. I always think about shoveling because I don't, you know, anyway. So if we look at this, you know, it doesn't necessarily scream, I'm a passive house. It looks like maybe every other house in the design. So again, this is a picture of it. The other one is using a trom wall. And this is basically, you know, the sunlight hits the window. You've got a window. And then you have this wall in there, and your wall is this your you know, your mass wall. They call it a trom wall. It's anywhere from, I would say, 8 to 16, but I'd say usually 12 inches is pretty common. It's going to be made of masonry or some sort of darker colored material. The glass that's going to be mounted on the front of it is typically about an inch away. And that glazing isn't necessarily part of the thermal envelope. We want that heat to come in and infiltrate that wall. So, you know, depending on where it is and what it's being used for, the glass may not be, I just want to, you know, make sure everybody's aware that that glass may not be part of that thermal envelope or part of it. And this is where it heats up this side of the wall, it makes its way through the wall, and then it goes ahead and it comes out into the structure itself. So here's an example of a trom wall. This is from the interior side looking at it. And then this is an example of it from the exterior side. So you can see it here. Whoop, you see it here, and then you see it from the other side, and it doesn't, in my opinion, it doesn't impact the design so much. Everybody's like, oh, that's going to take up so much space. It really doesn't, right? Anyway, so the third one is to have like an isolated gain. And basically it's kind of like having a sunroom. Often I see it being utilized as a sunroom, but it's still isolated from the remainder of a house. You might have a door or windows or other openings that would go into it. But basically, it's the entirety of the space that ends up collecting the heat. And it's placed there, and then it, you know, moves through, maybe, you know, through a wall or whatever the case may be. A lot of times I see it being utilized as a greenhouse too. So anyway, that's passive solar. Anybody have any, it's very brief, really quick, any questions concerning it? I went on a really brief overview of it. All right, let's look at our next one. How many of you have had the privilege of a project utilizing light straw clay construction? Anybody yet? Okay. Well, this has been in the code. I believe it made it into the 2015 edition as an appendix. And basically, it's kind of giving you guidelines. It's utilizing natural materials to be an infill. Oh, hempcrete. That's a big one that's coming up. I'm actually having a lot. I actually thought about including that into the class. And I probably should have, but anyway, probably similar to clay straw, not exactly, but similar conceptually wise. So basically, there are some requirements for it. It gives us basically how do we use that clay straw to determine that it meets the requirements that we have for the thermal envelope. And so there's some very specific parameters in here, right? It lets us know, okay, we have a there we go. We have a density of pounds per square foot of 10. And so now we have straw that's going to be 6.7 of it. And then the remainder of it is the subsoil, right? Because there we go. And then we're going to have 1.55 gallons per cubic foot of water in there. Now, in this design, it tells us also how much clay is going to be in that subsoil. So this one tells us that it has to have a minimum of 70%. And then it also gives us what our ratio is. So our ratio of clay silt ratio, our subsoil testing method, and then it has how thick is our wall actually permitted to be when utilizing this density for our straw clay. So it gives us that our maximum is 15 and our R value for this is 1.8. So let's do this really quick. Did it show up? It did. Okay. So let's multiply 15 times 1.8. That gives us an R value of 27. So this design gets us so close to the opportunity of just meeting the R value prescriptive path. But obviously it doesn't quite get us there. We're R3 short. So you may have to utilize like the res check to kind of trade off a little bit of that wall value to then go ahead and utilize maybe more insulation in the ceiling or better windows, something that's going to trade off that particular wall values. There's not a whole lot when it comes to straw clay information when it pertains to energy, but I still think it's a good one to kind of talk about. Straw bale. How many of you have had fun with straw bale construction? Anyone? All right. And I'm sure you had a lot of fun with that, Erin. So straw bale is really unique. There was a big push for a while there with straw bale construction, especially even here in Colorado. We actually have quite a bit of straw bale construction in Colorado, but now we have an appendix, our Appendix S here. It's Appendix S in the 21 and BJ in the 24. Now the sections that I'm referring to is going to be Appendix S. I didn't put the correlating sections for 24, but there weren't any changes in them. So they are the exact same. So the scoping in here is basically that you're going to do everything that's required within the base of the code, except for what is being called out here within this particular appendix. So the first thing when it comes to energy, you know, I think we all, when we think of energy, I think everybody thinks about insulation in a wall, right? So we have to think about that thermal envelope and how much R value does the straw bales actually have. And the great news is we have a way of being able to determine that because it's been provided for us. So depending on the direction that the bale is actually being placed will determine how much R value that you get. So if you have the straw bale is laying flat, then you get an R value of 1.55. But if the straw bale is being laid on its edge, right, like this, where here on this, then you get an R value of 1.85. Now, what I do want to tell you is, you know, I've had somebody say, well, how am I going to know which direction it's being laid on? Well, if you notice in this design, it shows you the binding as being up and down. And that lets you know that it's being laid on its side flat. If you see the binding from, you know, where you're standing and it's all, you know, visible, it's a wall of binding, then you know that it was laid up on its edge, or I call it top and bottom. So we got side, top, and bottom. Aren't you glad I used my hands? Because if I explained it without my hands and arms, you might not have understood. All right, so the next thing people think about is, okay, so we figured out the insulation, we met the requirement for those walls. As far as insulation, right, you still have to follow what the R value requirement is for wood framed walls, because here, as you can see, here's a design, a wood design, a design of straw bale, and this is how, you know, how they're going to put the bales in between all of that. So that would fall under the wood, right? Because it's wood or other. This falls under as an other. And so you would follow that if you're in the 21, you know, R30, R20 plus 5, R13 plus 10, that kind of design. Now, remember, it also talks about you can't have a vapor retarder utilized. So make sure that all the components are being complied with when it comes to the straw bale. The other thing is air leakage. You still have to follow the criteria of, you know, what we would have in table R402.4.1.1 or 402.5.1.1, depending on what edition you're on. So you're going to follow all of those requirements, and you're still going to be required to have a blower door test performed on that building. And this image is a test being performed on a straw bale house. So it's done and they passed. They just you have to be mindful, just like everything else, about your air sealing and how that goes. So the other thing is keeping in mind, you know, I think after you talk about the thermal envelope, at that point, now you're really treating everything else as the way it should be, right? Manual JS&D, insulate the ductwork, insulate the water piping, do duct leakage testing, ventilation testing, depending on, you know, obviously what edition of the code you're on. You're going to seal up all the ductwork, the air handler. We're going to have thermostats in there. None of that changes at this point. Neither does anything change when it comes to 404. right? So with 404, we would still have high efficacy bulbs and lighting controls for the interior and exterior, just kind of, you know, depending on what edition of the code you're on, but those requirements would still come into play for this type of construction. Now for straw bale, depending on which compliance path they chose, is going to entail whether or not they have to comply with 408. And also depending on what edition of the code you're on as to whether the compliance path is complying with 408. So if you're on the 2018, you can go to sleep for the next couple of minutes. If you're on the 21, then you know that if it's prescriptive, they pick one out of 408 and they're done. If they go total building performance, they have some options about how they could comply, which includes doing one of the items within the additional efficiency options and not including that into their calculations for their building performance. Or if it's ERI, you know, they aren't going to do any of that. They just have to be 5% better. Now, in the 24, it's completely different. And you have to follow the parameters for each of those compliance paths as to how you kind of meet that criteria. But anyway, additional efficiencies probably are required, depending on a lot of things here. All right. So you guys have sat there for a few minutes. This is where we are going to test your knowledge a little bit. So when we talk about unusual construction, sometimes it's not just things like shipping containers or log homes or, you know, straw bale. It could be the types of materials that are going to be utilized and are, you know, coming into play. So I'm going to show you a picture. You guys are going to take a look at it, and you're going to give me your thoughts about what that material is, and then we'll go from there. So here's the first one, and it's located, it's probably easiest to see it up here. There's a little bit down here, but what do you guys think this material is? How many of you want a hint? Raise your hand. All right. Does this help? It is not fiberglass bats. It kind of looks like it, but it's not. It's not rock wool. That's a good guess too. How many of you want another hint? Oh, sorry, raise your hand. All right, this is the last hint I'm going to give. There we go. Yeah, good job. Good job, Erin. You're absolutely right. It happens to be sheep's wool or lamb's wool. Now, here's where it gets really interesting. Yeah, it is. It's wool. So why people are utilizing it, right? These are some characteristics or features that are being called out for utilizing this. They say that it has some fire retardants for it. It also has the ability for helping to mitigate with moisture. And the reason why they're calling out for that is because with the lamb's wool, the outer layer is resistant to the moisture while the inner layer absorbs it. And so it also has the ability to prevent condensation with it. Now, with that being said, it gets an R value about 3.5 to 3.8. So it's very comparable to fiberglass or even rock wool as far as the R value per inch that you can obtain from this. Now, the one thing I will say is I watched this show where they were showing you how to build a tiny house for an office, right? They were calling it a tiny building, and they were building it. And they were showing what you needed to do through this informational video, I think on YouTube. And they started installing sheep's wool. And I thought, ooh, they said, oh, for our insulation, we're going to use sheep's wool. And I'll be honest with you, until that point, I wasn't really paying attention on that at all, like at all. My husband put it on, and that was the end of it. But once they said that, I will say that my attention perked up, and I was looking at it and watching it. And what I had a problem with in this whole design was the fact of how they installed it. You still have to install sheep's wool per the manufacturer. And guess what? You actually cannot compress that insulation because it doesn't work. And so they, at one point, they were trying to put it in, and they were punching it into this spot to get it into the ceiling. And you could see how compressed and how poorly it had been installed. And I'll admit, I sent an email and I said, hey, you know, if you're going to show how to install this, you should install it. It shouldn't have been compressed. And they wrote back and they kind of said, it's very, hold on just a second. It's very similar to, I said, they said, were you just trying to criticize us or trying to offer, insight? I said, I was just trying to give you some information. And I said, I teach this all over the country. And if you're going to show a, how-to video, it'd be great if you actually showed how to install it properly, which is my biggest thing with these DIYs is they cram that insulation in there and they show it that way and they show how they do it like that. And for everybody who's watching that for DIY, right? I'm pulling up a video. It says to do it like this. What am I going to do? I'm going to do it like this. So they wrote back and they said, if you're not going to be, provide constructive criticism and you're just going to criticize, don't bother reaching out. And I'm like, I thought I was providing constructive criticism, but I guess not. So how you would actually install is, like I said, very similar to, rock wool or fiberglass bat. You're going to cut it to fit the cavity if it needs to be, but you basically want it to be installed side to side, top to bottom, and you don't want it compressed because, again, that's how it gets its R value for it. And so that's how the manufacturer states for it to be installed. That just wasn't how it had been installed. How about this one? What's this material? Oh, good. Thank you, Randy. I was trying to think of I didn't have an extra clue on here for it, but I guess I could put a wine bottle up there. Maybe that would spark everyone. But yeah, it's cork. It is a material that is getting, has been kind of utilized for a while there. And the reason for that is because people were liking the idea of cork because it's natural. It's recyclable, it's biodegradable. It does have some great noise canceling aspects to it, right? I don't know. Kirk probably would love it if my entire office was, done in cork because I sing. So it's also free of some of the toxins that some of the other materials actually contain in it. So it's been something that has had a quirk there going on for a while. But the problem is right now, how many of you have noticed that wine bottles have more screw caps than they do corks? Yeah, that's because it does take a while for cork to regenerate, right? For it to be redone because you're pulling, you're pulling the, shoot, I just had it from the tree. Anyway, you know what I'm talking about. And so while it is renewable, it's not an endless supply. So that is something to keep in mind with. So it does have an R value of a 3.6. There's a lot of really good things when it comes to cork. All right, what about this one? Anybody know what this one? Oh, you need to buy better. I've had really good and expensive wine that are going to the screw tops just because of the cork issue. So I drink wine with Steve, and you all, anybody who knows Steve knows that that is really good wine. Anyway, what do you guys think this type of insulation is? I gave you a hint. Shrooms, yes, it is mushroom. It's mycelia, right? And the good news with this one is, you know, it has a very vast range as far as how much bark. Yes, thank you, Dylan. It was bugging me. It has a range about what its R value is. So it can go anywhere from a 1.8 all the way up to 4. And there was again, a stint there, probably, I don't know, 6-7 years ago, where mushroom insulation was a big thing. It was probably, I would call it the latest fad of insulation. But the one thing I will say, mushrooms actually have kind of like that 2-for-1 positivity with it. Can anybody think of a positive thing about what mushrooms can do? And I'm not talking about medicinal. Regenerate, Aaron. Yes, that's what I wanted to talk about. It is a regenerative material that actually is it's easy to reproduce it and keep it going, right? It's not a kind of like, you know, going on with cork or anything of that nature. But what it does do, and you kind of hit on it a little bit, if we happen to have a leak in our water pipes, what do you think happens? And it is sustainable, yes. Well, if we have a leak in our pipe, most of the time we don't know until it gets to the point of, you know, damages being able to be seen, unless we happen to have, you know, a leak detection device, right? Which I don't see a whole lot here in Colorado. And other places I'll see where they install leak detection, but Colorado they don't. But what it does do, guess what happens when mushroom gets wet? They regenerate, right? So if a mushroom were to get wet, you would be able to see that there was a leak, because obviously something's going to have an issue within those walls. You'll see it. Trust me. I got to see images of a water leak that happened in a project that used mushrooms, and you could see. All right, that's the end of it, ladies and gentlemen. Thank you so much for participating and, you know, being a part of this. There is a survey. Oh, I couldn't type fast enough. How do you approach meeting the IECC with a passive solar house in the newer codes? That is a really good question, Aaron. Jumping back to that real quick, what I would say is you still follow the parameters of that thermal envelope. Where there may be a few little exceptions in the design is you may have to get maybe an alternative method, means, and a material when you're talking about the wall that you're going to utilize and the glazing that's going in front of it. Because again, that glazing is not being used as part of like trying to get sun in because I want to see the outside. We are trying to get the sun in, but we're trying to collect all that heat and sun on our wall, our mass wall or floor, whatever we're doing, to collect it all to be able to use it as that. So there may be some options that you have to utilize an alternative method, means, and material, but otherwise, quite honestly, you would just follow what the energy code tells you to do. There's the passive solar, in my opinion, has more of a design hurdle to it than it does necessarily complying with the energy code. I hope that helps. If not, you know, reach out to me. Here's my contact information. Andre's also feel free to reach out to us anytime you have any questions, especially when you get some unusual construction. I love looking at all of that and answering whatever questions you may have. And with that, I'm going to say have a wonderful rest of your Wednesday afternoon. And I hope to see a lot of you at the chapter meeting that's coming up, or at the chapter picnic tomorrow. And we'll have the picnic and meeting tomorrow, and training on Friday too. So hope to see a lot of you there. Otherwise, have a wonderful afternoon and enjoy the weather.